Good morning, students. In the previous class, we discussed about quantum numbers. As I told you, there are 4 quantum numbers. But in the last class, we discussed mainly about 2 quantum numbers. One is principal quantum number, and coming to the next one is azimuthal quantum number. After discussion about the azimuthal quantum number, we discussed about the energy of orbitals also. Because the energy of orbitals mainly depends on n plus L values. Right? Even the exception cases for hydrogen-like species also we discussed in the previous class. Now, regarding the energy of the substance, if they compare energy of substance in an orbit. Okay? Yes. Let us take the same orbit. For example, if you take third orbit, we have the orbit substance like 3s, 3p, 3d. Okay? Here n value is the same. So if I ask you that which one is having high energy, generally what we will calculate? We will calculate n plus L value. L value of s orbital is 0. For p it is 1. For d it is 2. Even though n value is same, as L value increasing, energy of the orbital also increases. So out of the substance in the given orbit, if I ask, what about the energy order? S orbital will have lower L value, so its energy is also lower when compared to p orbital. And the same it will have lower than d orbital, less than f orbital, less than g orbital, like that. Okay? Now, one more important thing about the azimuthal quantum number is azimuthal quantum number explains about orbital angular momentum of the electron. Okay? Note down. Orbital angular momentum of the electron. According to Bohr, we know the angular momentum of the electron mvr is equals to nh by 2 pi. Here, orbital angular momentum of the electron given by Sommerfeld is equals to root over L into L plus 1 into h by 2 pi. Okay? Root over L into L plus 1 into h by 2 pi. Means for the h by 2 pi there is no square root. In the examinations, sometimes instead of giving the formula for orbital angular momentum in this manner, once they give it in competitive exam, like this. Okay? So don't confuse with that. H by 2 pi can be represented with this sign. Okay? So note down both of these. Where L means, we know azimuthal quantum number. The values of L for different substances. Yesterday we discussed it. If they ask you to find orbital angular momentum for a particular orbital, the respective L value we have to substitute. Okay? For understanding purpose, one example let us discuss. Now, for example, orbital angular momentum of let us find for 3p orbital. Okay. Let us calculate the orbital angular momentum of 3p orbital. Here, what is the L value for p orbital? For p orbital, L value is 1, right? For s orbital 0. For p orbital, L value is 1. Now let us substitute in the formula. What is the formula to find orbital angular momentum? Formula is root over L into L plus 1 into h by 2 pi. So root over L into L plus 1 into h by 2. So if we substitute there, what is the L value here? So 1 into 1 plus 1 into h by 2 pi. Nothing but 1 plus 1 2. So it will be root 2 into h by 2 pi. Nothing but it can be written as h by root 2 into 5. Okay? So this root 2 in the 2 will be cancelled root 2 times. So h by root 2 5. Okay? If they give s orbital, any s orbital if they give, L value is 0. Then what will be orbital angular momentum value? Will be 0. Okay? And this is about azimuthal quantum number and energy of the orbitals. Now coming to the next quantum number. So the third one, that is magnetic quantum number. This is one of the typical quantum number. Okay? Till now we discussed two quantum numbers. Now the third one is magnetic quantum number. Can be represented simply by is represented as small m. Magnetic quantum number can be represented as small m, or even it can also be represented as m with the subscript L. Okay? Anything represents magnetic quantum number. Regarding any quantum number, first we need to focus on two things. One is what is the importance of that quantum number, means what it represents, and the second thing is values of that quantum number. Okay? Regarding the previous two quantum numbers, we know n values are always positive integers from 1, 2, 3, so on. Coming to the L values, we start from 0, 1, 2, 3, so on, up to n minus 1. Okay? Now coming to the magnetic quantum number, this magnetic quantum number represents this explains about, we know principal quantum number explains about size of the orbital as well as energy of the orbital. Coming to the second one, azimuthal quantum number explains about shape of the orbitals. Now coming to magnetic quantum number, this explains about orientation of orbitals. Okay? Magnetic quantum number explains about orientation of orbitals. Orientation means what? That is our first doubt. Okay? Size, shape, okay. But what is meant by this orientation? Orientation nothing but the direction in the way how they are present. Okay? In three-dimensional way, how they are present. For example, while representing the orbitals, I said px, p orbital along the x-axis. This p orbital along the y-axis. So these can be differentiated or designated using the quantum number which is known as magnetic quantum number. Okay? So magnetic quantum number explains about the orientation of the orbitals. Okay? Means the direction of the orbitals. Now, coming to the values, this is most important. Values of m is slightly different when compared to the previous two quantum numbers. Here, coming to the values of m, will be starts from minus L, will be ends with plus L. Okay? Values of m will be from minus L to plus L. Okay? So will be slightly confusing by looking at the statement like that. I know. So let us discuss or let us write the values of m for different subshells. Now first coming to the S subshell, let us take. Here somebody will get a doubt between a orbital and a subshell. So whatever we are saying actually S, P, D, F, generally we should say these as subshells. Okay? Within the subshells there will be different orbitals. We will get clarity. Now coming to the S subshell. What about the L value? We know for S subshell, L value is 0. Now coming to the M value, is there will be any minus 0 and plus 0? No, 0 is always 0. So M value is also 0. Okay? Now coming to P subshell, P subshell, what is the L value? L value is 1. When L value is 1, what about M values? M values will be from minus 1 to plus 1. Okay? Minus 1 to plus 1 means, once observe them. This whole thing generally we call it as P subshell. Okay? So these three are known as orbitals, Px, Py, Pz. These are known as orbitals. Now, minus 1 to plus 1. After minus 1, what will be the number? 0. Next, plus 1. Okay? So the three different values for a P subshell are minus 1, 0, plus 1. Okay? Note on this. Next. For P subshell, we got 3 M values. Now coming to the D subshell. What is the L value for D subshell? For P it is 1, for D it is 2. Okay? When L value is 2, what about M values? M values will be from minus 2 to plus 2. Okay? What numbers will come between minus 2 and plus 2? We will get 5 numbers. So means a D subshell will have 5 D orbitals. Okay. Now coming to this one, minus 2, after that minus 1, 0, the next plus 1 and then plus 2. Okay. So these are the m values for D or D subshell. Because its L value is 2, so m values will be from minus 2 to plus 2. What are the numbers between minus 2 and plus 2? Minus 2, minus 1, 0, plus 1, plus 2. Okay? So a D subshell contains 5 m values. Nothing but a D subshell will have 5 orbitals. Now coming to the last one, F subshell. What is meant by F? The L value is 3. So M values will be from minus 3 to plus 3. How many numbers will come between minus 3 and plus 3? Okay. Tell me the numbers between minus 3 and plus 3. After minus 3, next number is minus 2, minus 1, 0, plus 1, plus 2, plus 3. Okay? These are the numbers between minus 3 to plus 3. How many numbers came? So we got 7 numbers. It means F subshell will have 7 F orbitals. Okay? I will give you a simple form how to remember these values. First note of this. Okay. I think you got some idea about m values. Okay? The values of m will be from minus L to plus L. Okay? Now, note down one important point. The number of orbitals in a subshell. Okay? The number of orbitals in a subshell. Just now we discussed in a detailed manner. Okay? For S we got 1 orbital. So in the case of S, we can say either S subshell or S orbital. Because there is only 1 orbital, so anything will be same. But coming to the P, in the case of P subshell, we got 3 P orbitals. In the case of D subshell, we got 5 D orbitals. So to remember directly, the number of orbitals in a subshell is equals to 2L plus 1. Okay? The number of orbitals in a subshell is equals to 2L plus 1. If you have a doubt, let us cross check for P subshell. Okay, let us start from the first one, S subshell. In the case of S subshell, how many orbitals are there? Its L value is 0. So 2 into 0 plus 1. 1. That's what we got practically also. Now coming to P subshell. 2 into, what is the L value for P? It is 1. So 2 into 1 plus 1. 2 plus 1 it is 3. That is why we are getting 3 M values for a P orbital. Now, for D subshell, so 2 into its L value is 2. So 2 2s are 4 plus 1. 5. Okay? What are the 5 values we got for D subshell? minus 2, minus 1, 0, plus 1, plus 2. Okay? Now coming to the F subshell. The 2 into 3 plus 1. 2 3s are 6 plus 1, 7. Okay? So for a F subshell, we will get 7 orbitals. So if they ask you to find the number of orbitals in a subshell, the formula is 2m plus 1. Okay? One more important thing. Number of electrons in a subshell. We know the number of orbitals in a subshell is 2l plus 1. And yesterday we discussed any orbital can accommodate 2 electrons. So the number of electrons in a subshell is equals to 2 into 2l plus 1. I think you understood this one, why we got like this. The number of orbitals is 2l plus 1. Every orbital can accommodate 2 electrons. So that is why the number of electrons in a subshell is equals to 2 into 2l plus 1. Okay? Remember this. This is about magnetic quantum number. So out of the 4 quantum numbers, we discussed 3 quantum numbers. Now coming to the 4th quantum number, a very easy one, it is known as spin quantum number. Okay? Spin quantum number is our last quantum number. While discussing about the quantum numbers, starting one point I told you, the first 3 principal, azimuthal and magnetic quantum numbers explains about position of orbitals in the atom. But coming to the 4th quantum number, this spin quantum number explains about position of electron in the orbit. Okay? So using these 4 quantum numbers, we can distinguish between one electron to other electron in any of the atom. Okay? Even within the atom also. Now coming to the representation, spin quantum number is represented by S. Okay? It is represented by the letter S. And it was given by 2 scientists. One is Uhlenbeck and Gauss. Okay? Spin quantum number was proposed by Uhlenbeck and Gauss. Now regarding the quantum numbers, we know we need to remember 2 main points. One is what it explains and what are its values. Now coming to the spin quantum number, it explains the or it represents the spin of the electron. Okay? Spin quantum number explains about the spin, nothing but the rotation of the electron. Here we need to know one point. Generally, about the planetary model we know how planets revolve around the sun we know. We know all these planets revolves around the sun. Like we know mainly about Earth. Our Earth revolves around the sun. As well as we know that even Earth revolves around itself also. Correct or not? Everybody knows that because of that we will get this day and night. Right? Earth revolves around the sun as well as it revolves around itself also. In the same manner, electron also revolves around the nucleus. Along with that, it revolves around itself also. Okay? So as like the earth, the electron also revolves around itself and revolving around the nucleus. Okay? So because of revolving around the electron itself, it will get some magnetic moment that is known as spin magnetic moment. And even while it is revolving around itself, the direction of rotating the electron will be represented by spin quantum number. Okay? Now coming to the values of spin quantum number. If the electron revolves in a clockwise direction or anti-clockwise direction. So to distinguish between clockwise and anti-clockwise spin quantum number, we have two values. One is plus half. This plus half represents clockwise rotation of electron. And coming to the next value, minus half. It represents the anti-clockwise rotation of electron. Okay? So the electron rotates around itself, either in clockwise or anti-clockwise. It represents. So only S values are two values, plus half as well as minus half. Now you are coming to the formula to find spin magnetic moment. Spin magnetic moment of electron, as I already told you, due to the revolution of electron around itself, the magnetic moment developed is known as spin magnetic moment. The formula to calculate this one is root over S into S plus 1 into H by 2 pi. Okay? So same as orbital angular momentum. In the case of orbital angular momentum, we got the formula in the same way, but instead of S, we have small l. Okay? Because orbital angular momentum is calculated using azimuthal quantum number. Spin magnetic momentum can be calculated using spin quantum number. Okay? So this is about the four quantum numbers. As I told you in the previous class, the quantum numbers concept is very important for competitive examinations. Even I explained about the weightage of this topic in the competitive exams. So we need to discuss different model questions based on quantum numbers. Okay? But I told you already, there are no numericals, no formulas, nothing. Only based on this theoretical concept only, is based on the values of four quantum numbers only. They are asking the questions in different ways. Okay? All the types of questions we will discuss in the class. But before discussion about these type of questions, you need to know about electronic configuration. Okay? How to fill the orbitals with the electrons. Somebody, maximum number of students already may have idea about how to fill the orbitals. Okay? But still, I will explain once how to fill the orbitals along with the rules. Okay? So after completing the electronic configuration, then we will discuss the questions based on quantum numbers. Okay? Because when we have clarity about electronic configuration, then whatever the model question they ask, you are able to solve easily. So first let us finish that topic. Then we will discuss questions based on the quantum numbers. Okay? So first give the subheading is rules for filling orbitals. Rules for filling orbitals with electrons. Anyway, we will fill the orbitals with electrons only. Okay? We cannot fill the orbitals with other things. Because protons, neutrons will be in the nucleus. So we fill the orbitals only with the electrons only. So give the subheading as rules for filling the orbitals. There are mainly 3 rules are there. Now coming to the first rule, maybe some of you in the lower classes may have idea about this rule. Aufbau principle. The first and basic rule to fill the orbitals is Aufbau principle. Okay? This is the basic rule to be followed while filling the orbitals. Maybe while filling about the orbits, whatever the rule we are following, the same rule will be followed to fill the orbitals also. What you learned in the lower class, for example, if you have different orbits, the electrons first enters into first orbit, then they goes to second, then they goes to third. That is what we learned in the lower class. Now coming to the filling of orbitals also, the same principle we follow, which was given by Aufbau. The rule is, so according to this principle, electrons will be entered. Right, the rule is, according to this principle, electrons will be entered into the orbitals with the lower energy. Okay? In simple way, the electrons will be entered into the orbitals with the lower energy first. Okay? So first the electrons will enter into the orbitals with the lower energy. Now when the electrons will be enter into other orbitals means after completely filling these orbitals, then the electrons will be enter into the higher energy orbitals. After completely filling these orbitals, then the electrons enter into after completely filling the orbitals with lower energy, then the electrons enter into higher energy orbitals. Okay? It is not a new rule. Whatever you did in the lower class for filling of orbits, the same way. The electrons will be entered into the orbitals with the lower energy first. Okay? After completely filling these lower energy orbitals, then the electrons enter into higher energy orbitals. Okay? Even yesterday we discussed about the energy of the orbitals clearly. I hope you remember the calculation of energy of orbitals. How to calculate energy of orbitals? Using n plus L value. Okay? Once I will write the energy of orbitals. What is the order of energy of orbitals? For example, we have in the first orbit we have 1s orbital, second orbit 2s, next 2p. Now to which the electrons will enter first? 1s, then 2s, then 2p. How can we come to know? It is depends on n plus l value. Correct or not? Energy of the orbital depends on n plus l value. So 1 plus 0, 1. So 2 plus 0, 2. 2 plus 1, 3. Yesterday we calculated for the orbitals. So based on that now I can say 1s orbital is having lower energy than 2s orbital. Then 2p orbital. After 2p, 3s, then 3p, then 4s, then 3d. The people will get doubt. Sir, after 3p, why not 3d? Why did you went for 4s? Okay, let us calculate n plus l value for 4s orbital. How much? 4 plus 0, nothing but 4. Now coming to 3d orbital. In the case of 3d orbital, it is 3 plus 2, 5. So which is having higher n plus l value? 3d orbital is having higher n plus l value. So that is why 4s is written first. So 4s is having lower energy than 3d. Now after 3d, which orbital will come? That is 4p. Okay? Let's check for 4p also. 4p means how much will come? 4 plus l value for p orbital is 1. 5. So again doubt. That both are having same value. Then why did you written 3d first? That is what we discussed yesterday. The last point in the yesterday's class. You written clearly in the notes also. What you written there? When n plus l value is same, in such cases, the energy of the orbital depends only on the n value. Okay? Higher the n value, higher will be energy. Lower the n value, lower will be the energy. Right? That is why I written the order like this. Okay? It will be very difficult to write all the orbitals. Even it will be difficult to by heart all these orbitals. So that is why instead of remaining all these orbitals, I written only up to 4p because majority of the cases to write electronic configuration up to 30 elements, this order will be enough. Okay? But when higher elements when they give, how can we remember all the order? Will be very tough. So that is why we have one of the easier way to know the energy of the orbitals. That was given by Euler. The diagram given by him is known as Euler's diagram. Once let us discuss about that Euler's diagram. Okay, this Euler's diagram we are using to know the order of filling the orbitals. Nothing but the energy of the orbitals. Euler's diagram. I think in the lower class only most of you may know about this diagram. But anyway, first look at this one. What is orbitals we have? 1s. In the second orbit we have 2s as well as 2p. 3s, 3p, next 3d. 4s, 4p, 4d, as well as from the fourth orbit we have F. The first orbit we have only S. Second we have S and P. Next SPD. Next SPDF. Now coming to fifth orbit, we will get 5P, 5D, 5F, 5G also. Okay? But I am not writing all this. As I told you, up to this SPDF filling only, for all these known elements it is enough. Okay? So, from the diagrammatic point of view, I am drawing like this. 7s. Okay? So according to Mendeleev diagram, the electrons first enter into 1s orbital first. Okay? After filling 1s orbital, the electron will goes to 2s orbital. After filling 2s orbital, then the electron goes to 2p. Then the electron goes to 3s orbital. Okay? After filling 3s, then it goes to 3p. Then 4s orbital. After filling 4s, then the electron goes to 3d, 4p, 5s. After filling 5s, then 4d, 5p, 6s. Okay? 4f, 5d, 6p, then 7s. Continuation diagram also will be in the same manner, but no need of that much big diagram. So for understanding point of view, I given like this. So if we ask energy of the orbitals, what order we got? 1s. After that we got 2s. Then it is going to 2p, then 3s. Next the electron goes to 3p. Next 4s. Then it went into 3d. Then 4p less than 5s less than 4d less than. Okay, anyway, write in the notes. 4d less than 5p, then the electron goes to 6s orbital, then it goes to 4f, then 5d, then the electron goes to 6p, then 7s. Okay? This is only up to few orbitals we given. Can you remember all this order? I think as a normal human being, it will be difficult to remember all this. Okay? If you are a brilliant man, then only if you are capable to by heart all this way, your wish. But my scientists go for this one. But every student compulsory should remember the order of the orbitals, at least starting two lines, whatever around. Okay? Because every time for filling up the 20th element or 25th element, it will be useless to write all these Euler's diagram. Got my point or not? If I ask you to write electronic configuration of the 15th element, if you write Euler's diagram and then if you start to fill the electrons, it will take half an hour. Okay? So that is why at least to write the electronic configuration of 30 elements minimum, you need to remember this order. Okay? Once in the evening time, you practice the order of filling these orbitals. Next in the next classes, we will discuss how to fill into these orbitals. Okay? Now this is about first rule, half-bow principle. According to this, electrons will be entered into the lower energy orbitals first. Okay? Then copy neatly this Euler's diagram. As I told you, regarding electronic configuration, we have three rules. Now we discussed half-bow principle. Now coming to the other rules are Hund's rule and the Pauli's rule also. The remaining rules we will discuss in the next class. After discussing the rules, then we will discuss electronic configuration. Okay? Today's your work is once go through the 4 quantum numbers whatever we discussed and go through the rule whatever I explained. Okay? Regarding the Euler's diagram also, once just you note down in the notes and once you practice. As well as every one of you by tomorrow's class, every one of you should remember this order. Not all these, only up to at least this one. Okay? Then it will be easy to understand how to fill the orbitals with the electrons. Right? About all these we will discuss in the next class. Thank you.